Good afternoon. This presentation will cover what is transcranial direct current stimulation, or tDCS, what is major depressive disorder, or MDD, the neuropsychology of depression, tDCS treatments, and directions for future research. So, what is transcranial direct current stimulation? tDCS is a safe and painless form of non-invasive brain stimulation used to produce changes in cortical excitability. The use of tDCS involves the application of a low, direct electrical current, usually between 1 to 2 milliamps, for the duration of 5 to 20 minutes. The current is administered through electrodes attached at specific points on the scalp. The goals of a study or treatment will dictate the location of electrodes. The placement is important because each electrode has a different function. The anodal, or positive electrode, enhances local neuronal excitability, and the cathodal, or negative electrode, does the reverse. The placement is standardized by utilizing the International 1020 EEG system. This is an example of the EEG system. What distinguishes tDCS from other forms of brain stimulation is the way in which neuronal activity is either excited or inhibited. While transcranial magnetic stimulation, or TMS, or repetitive transcranial magnetic stimulation, RTMS, excite local neurons directly, tDCS modulates the action potential of neurons by altering resting membrane potential. What is major depressive disorder? Major depressive disorder, or MDD, is a serious medical condition that causes feelings of guilt, sadness, or a lack of interest in activities that you would otherwise enjoy. According to the American Psychiatric Association, MDD affects an estimated 1 in 15 people a year. Symptoms can include decreased mood, fatigue, increase in negative emotions, and even thoughts of suicide and death. The prevalence and seriousness of the illness make it a priority for researchers and healthcare professionals. Neuropsychological evidence for MDD is illustrated by some of the key symptoms of the disorder itself. Symptoms such as dysregulation of circadian rhythms, cognitive processing, and abnormalities in appetitive and psychomotor functioning. Lesions or abnormalities in brain regions such as the amygdala, hippocampus, and cerebellum can also influence MDD in a subject. A literature review by Chanel et al. In 2003 illustrates the importance of the autonomic nervous system in affecting the onset of neurological disorders like depression. However, the review also suggested the cerebral cortex, and more specifically the prefrontal cortex, may be more directly involved due to its role in the moderation of emotions and motivation. Many studies have also reported asymmetry in the activity of the left and right hemisphere. The valence lateralization theory insists that the left prefrontal cortex is responsible for positive emotions, and the right prefrontal cortex the same for negative emotions. In sufferers of MDD, neuroimaging has shown an inhibition of action potential, or a hypopolarization, of the left prefrontal cortex, and an increase in neuronal excitability of the right prefrontal cortex. Happy and healthy subjects, on the other hand, are characterized by higher excitation of the left prefrontal cortex. This has led to the theory of hyperfrontality. tDCS in the treatment of MDD. It is the asymmetry in brain regions that has become the rationale for treatment of MDD with tDCS. According to a literature review by Barnaby and Haffman in 2018, the placement of electrodes is aimed at stimulating the left prefrontal cortex and inhibiting excitation of the right prefrontal cortex. To this end, electrode placement is generally in the vicinity of the F3 and the FP2 on the 1020 EEG system. A randomized clinical and sham-controlled study by Liu et al. In 2012 positioned an anodal electrode at the PF3 position and a cathodal electrode at the F8 position. A current of 2 milliamps was applied for 20 minutes. The study found that the treatment group showed significant improvement on the Montgomery-Åsberg Depression Rating Scale than the sham-controlled or placebo group. A systematic review and meta-analysis by Shiozawa et al. In 2014 examined 7 randomized clinical trials. The analysis found tDCS was significantly superior to sham groups for the treatment of major depressive disorder, with a medium significant effect size in both continuous and categorical outcomes. These findings correspond with a similar review by Barnaby and Haffman in 2018. Limitations of tDCS as a treatment in major depressive disorder come from a variety of sources. In some trials, subjects are often utilizing other treatments for depression, such as medication, which can weaken effect size. Another limitation is the size and heterogeneity of subject samples. The difference in the subject's comorbidities, illness severity, age, sex, or weight can make clinical testing difficult. The significant effect of sham-controlled trials in the treatment of major depressive disorder have made it a viable direction for future study. Further research is needed, however, before tDCS can be used clinically. One focus should be on electrode placement and stimulation variation in order to improve the compatibility of future research. Many studies would also advocate for longer controlled studies assessing the long-term efficacy of the treatment. In conclusion, tDCS as a form of treatment is both safe, non-invasive, and inexpensive. The efficacy and heuristic value will only improve as future research and larger clinical trials are conducted. Thank you.